Hello and welcome back to Geometry. We're in Chapter 6, Section 2, talking about bisectors of triangles. Couple terms to begin with. Concurrent means when three or more lines, rays, or segments intersect at the same point. That point is called the point of concurrency. So if you look at this triangle right here, we've got lines, segments, they intersect right there at point P. Now in a triangle, if three perpendicular bisectors, alright, so we've got bisectors here, if they're concurrent, that means if they meet at the same point, the point of concurrency is called the circumcenter of the triangle. Alright, so our theorem here is the Circumcenter Theorem, and that means in a triangle, the circumcenter is equidistant from the vertices. Okay, so this point P is the same distance from A as it is from C. And that makes sense. If you look at this triangle right here, if this is a perpendicular bisector of that line, then we know by the perpendicular bisector theorem that that point is the same distance from A as it is from C. Same thing goes here for B and C from this triangle, BPC, same thing for this side. So, we know that if these are perpendicular bisectors, then these lengths are the same, are equal. Alright, so here's a real world, real life problem. We have snack carts that sell frozen yogurt at points A, B, and C. All three carts are the same distance from the frozen yogurt distributor. Find the location of the distributor. Alright, so we're going to do this with a ruler and a protractor. So we're going to mark for ourselves here. No, let's see, let's turn that right there. And measure from there to there is, get that aligned. There we go. Alright, we got 12 centimeters right there, so mark it at a halfway mark. That's 6. Oh, come on, there we go. Okay, then measure this side here. We have from there to there is 8, so we will mark it at 4. Mark this at 4, and then finally over here, we have 10 centimeters, so we will mark this at 5. Alright, there's 5. Okay, move that out of the way. Now I've got my halfway marks. I will take my protractor and do a 90-degree angle on there. So there we have 90 degree, line it up with that point, the halfway mark, and that line goes like so. Okay. Next, I'll line it up over here. 90 degrees. Goes like this. And then line it up with my third line. Turn this around. There we go. And lined up. 90 degrees is right there, and those were not the most beautiful of lines, but I have found the point where the distributor is right here. Point D is the distributor. Boom. Alright, now there's a cool fact about the triangle bisectors. That point, the circumcenter, if I take a circle and I use this circumcenter as the center of a circle, wait for it, boom. How cool is that? The outside points land on that circle, which makes sense because A is the same distance from P as C is from P. It's like the radius of a circle. So this triangle is inscribed by a circle. Inscribed into a circle. Now if I have a right triangle, notice that the bisector here meets the other bisector on the hypotenuse. Okay, so that circumcenter is on the third side. So if we do the circle here, make sure I line that up right. There we go. Very cool. So, quick little summary of that. If it's an acute triangle, then P, circumcenter, is inside the triangle. If it's a right triangle, it is on the triangle, on the hypotenuse. And if it's an obtuse triangle, then it's going to be outside of the triangle. So if we do a bisector here, then that wouldn't meet the bisector on the long side inside. All right, finding the circumference of the circumcenter of a triangle. Okay, here we're given some coordinates. Notice that x and x are the same here. Okay, so if A is 0 and 3, and, what am I doing? 0 and 3, and B is 0 and -1. If their x values are the same, that's a vertical line. Okay, and then here the y values are the same, so that would be a horizontal line. So there was A, B, and then C is 6 and -1. So there's a horizontal line. It's really easy to find the midpoint of horizontal or vertical lines because you just find the middle between the two. Okay, this line is 4 units, so we find the middle between the two. And then connect the outsides like so. Okay, I want to find the perpendicular bisector. So I'm going to make a line that's in a right angle right on this midpoint. Now, if it's in a right angle, if it's perpendicular to a horizontal line, it's going to be a vertical line, right? If it's perpendicular to a vertical line, it's going to be a horizontal line. So I need to find that point where this line, x equals 3, intersects with y equals 3, and they intersect, y equals 1. Getting ahead of myself here. And they intersect at 3 and 1. So that point, and now I only need 2 of the bisectors because the third bisector would also intersect there, right? I could use that one to check it. All right. The Incenter Theorem states that this point P, the incenter, is the same distance from every side. Okay, I know that this is the distance because of the right angle here. And so PF is the same length as PE is DE. And if that's the case, then this line AP is an angle bisector, which means this angle is the same as that one. And this is an angle bisector. This angle is the same as this one. And so is this the same as that one right here. All right. Using this, here we have an example. We know that ND is 5x minus 1. We know that NE is 2x plus 11. And look at these angles. This is an angle bisector, this is an angle bisector, and this is an angle bisector, which means that N must be the incenter. And therefore, I can state that ND is equal to NE. So, 5x minus 1 is equal to 2x plus 11. And then we solve this. Subtract 2x from each side. And that cancels out. And add the 1 to each side. And we get 3x is equal to 12. Divide by 3. And x is equal to 4. The question was find NF. Alright, so NF is not 4. X is 4. We need to plug x back in. So 2 times 4 plus 11. 2 times 4 is 8 plus 11 makes that length 19, which is the same as ND, which is the same as NF. So NF, because NF is equal to NE, NF is 19. Can NG be equal to 18. Explain your reasoning. No, because the shortest distance between a point and a line is a perpendicular line. Right? This is not perpendicular, and this is 19, so that can't be shorter than this one. A city wants to place a lamppost on the boulevard shown so that the lamppost is the same distance from all three streets. Should the location of the lamppost be at the circumcenter or incenter of the triangular boulevard? Explain. It should be at the, well, we want to be the same distance from all three streets, not all three street corners, right? And the same distance from each side is the incenter. So we want the incenter because the incenter is the same distance from all three sides. Boom. There you have it, ladies and gentlemen. Triangle bisectors. Good times, as always. See you in the next lesson.